Civil Engineering by Justin Wong. The subsets of engineering in general are civil engineering, computer engineering, mechanical engineering, electrical engineering, aerospace and aeronautical engineering, biomedical engineering, chemical engineering, and industrial engineering. Specifically for civil engineering, it deals with infrastructure analysis, design, construction, and maintenance, while also including structural engineering, water engineering, waste material management, and foundation engineering. The disciplines of civil engineering are architecture and planning, building materials technology, construction technology and management, environmental engineering, geotechnical engineering, hydraulics, water resource and irrigation engineering, remote sensing and GIS, and structural engineering. For architecture and planning, it focuses on enhancing the appearance of buildings and maintaining heritage. Also deals with proper planning of towns and cities, which includes the layout of the roads and buildings and such. Building materials technology focuses on the materials used for construction, for example, brick, tile, stone, steel, sand, and other materials, while also keeping in mind the durability and use of the material and its impact on the environment. Construction technology and management includes planning, scheduling, and execution of construction activity related to the project, while also placing an emphasis on new construction practice, use of appropriate and local technology, and the safety of men and using materials. Construction managers provide quality control and ensure projects are completed on time within budget. Environmental engineering uses technology to save nature from human and natural abuse or pollution. It also deals with water collection, purification, and supply, wastewater collection, treatment, and disposal, while also controlling all types of pollution. Geotechnical engineering, you have to understand ground behavior and the interaction between soil and the structure that will be built on top of it. It includes foundations, slopes, retaining structures, highway pavement design, embankments and earth dams, tunnels, underground structures, and deep cuts. You also have to assess soil or rock quality to decide if it is safe for a structure. Hydraulics, water resource, and irrigation engineering. This includes mechanics of water or fluid flow, identification and utilization of available water resources, river and lake management along with groundwater utilization, recharge, and rainwater harvesting. Design drainage systems, detention, retention ponds, navigational waterways, flood control levees, dams, and lakes. Remote sensing and GIS. GIS, or Geographic Information System, is a high-tech equivalent of a map. It's a means to locate ourselves in relocation of the world around. It deals with measurement, mapping, monitoring, and modeling of geographical information around us. Structural engineering. Structure is the assemblage of two or more basic elements such as a beam, slab, or column. It deals with limiting states of collapse and serviceability. You also plan positions of different elements in design. You also work with repair, rehabilitation, and maintenance with designing dams, bridges, stadiums, and auditoriums. Surveying. Surveying is a key component of civil engineering, which means a collection of topographic features of a location for future construction, in which you would collect topographical data, calculate and analyze that data, and create design maps. Transportation engineering. Planning, design, operation, and management of transportation systems, You also have maintenance and upgradation of docks, harbors, airports, railroad system, bound on requirements, and population growth. For roads, a road is an identifiable route, way, or path between two or more places. It's typically smoother, paved, or prepped for easy travel. Based on NAGPRA road plan, there are national highways, state highways, major district roads, and village roads. Based on road surface, there are bituminous, concrete, waterbound macadam, and mud roads. Bridges. A bridge is a structure built to span a gorge, valley, road, railroad track, river, body of water, or any other physical obstacle. Structural efficiency is the ratio of load carried to bridge mass, while economic efficiency is site and traffic dependent, and the ratio of savings by having a bridge. Based on the action, bridges can be divided between beam, cantilever, arc, suspension, cable stayed, and truss bridges. Based on material, can be divided by concrete, steel, timber, or composite. Based on support, simply continuous fixed cantilever. Based on purpose, road bridge, rail bridge, and rail pedestrian aqueduct. Dam. A small dam is less than 10 meters high, and it goes up and up until a major dam is above 150 meters high. Based on purpose, it can be hydroelectric, irrigation, water supply, flood control, habitat. The material used can be masonry, concrete, timber, steel, earth, rockfill, composite. And based on its action, it could be a gravity, arc, saddle, check, diversion, overflow, or cofferdam.